You ever have one of those million-dollar app ideas, but then you wonder, how do I actually turn this into something real? Something that could, land me a job? Well, the secret sauce isn't just the code. It's having a professional blueprint. And that's exactly what we're going to break down. So, what's the real difference between a weekend project you build for fun and a serious career move? It all comes down to knowing the process, the professional process, the structured, methodical way real software gets built, tested, and eventually trusted by millions of people. And honestly, the best way to think about this whole professional process is like a roadmap. It's the thing that guides you from that first little spark of an idea all the way to a big successful launch and beyond. It's what keeps you from getting totally lost in the woods. All right, so here's the roadmap for our little journey today. We're going to look at the main blueprint, the SDLC, then figure out how to choose a development model. We'll get into the fun part, the art of breaking things. Then we'll see what happens when code goes wrong, and finally, wrap it all up with how you can build your own path. Okay, first stop. Let's talk about the big picture blueprint. This professional roadmap that every single project follows, it has a name, the Software Development Lifecycle, or as you'll hear it called all the time, the SDLC.
So what is the SDLC really? Well, it's the whole shebang. The entire structured process that takes you from A to Z, from idea to finished product. And let me tell you, following this cycle, that's what separates the pros from the hobbyists. It's how teams make sure they don't waste a ton of time, blow through their budget, or worst of all, tank their reputation with a buggy, broken release.
This whole journey is broken down into 5 key stages. First up, requirements. You gotta know, what's the problem we're actually solving? Who is this for? If you don't nail this, nothing else matters. Next is design. This is where you figure out how it's all gonna work, what it'll look like. A good design now saves you from massive headaches later. Then comes implementation. That's right, this is where the coding actually happens. After that, it's testing. Your job here is to try and break everything you just built before the user does. And finally, evolution. Because great software is never really done, is it? It's always being launched, maintained, and updated. And this quote from Steve Ferber really hits home just how crucial that design phase is. He says, they get a few people in a room and start drawing block diagrams on a whiteboard. Think about that. Professionals don't just jump in and start hammering out code. They get together, they plan, they sketch out the entire structure first. The planning always comes before the programming. All right, so we've got our roadmap, the SDLC. But now we have to choose which route we're going to take. See, there are different development models, and each one is kind of like taking a different highway. They're all suited for a different kind of trip. Let's check out 2 of the big ones. On one side, you've got waterfall. Think of it like building a house. You finish the foundation completely before you start on the walls. You can't go back. It's linear, it's rigid, but it's perfect for projects where the requirements are set in stone, like building software for a rocket. Then you have agile. This is the complete opposite. It's all about flexibility. You work in these short bursts called sprints. You build a basic version fast, get feedback, and adapt. It's absolutely perfect for projects where you know things are going to change on the fly.
Okay, here are a couple more. The V-shaped model. You can think of this as waterfall's super cautious cousin. For every single development step you plan, you also plan a corresponding testing step, right from the very start. It's all about verification, and it's great for projects that have zero room for error. Then there's the incremental model. The whole idea here is to deliver the product in working chunks or increments, so the user gets a basic but functional product really early on, and you just keep adding to it.
Okay, let's bring this down to earth. Imagine you're building a simple homework planner app, but your ideas for new features are constantly changing. You add one thing, then you think of something cooler. Looking at these models, which one would you pick? If you're thinking agile or maybe incremental, you're right on the money. You need that flexibility. All right, let's move on to what might be the most critical and, honestly, the most fun part of the whole process, testing. And here's the twist. The goal isn't just to prove your code works. The real goal is to actively, deliberately try to break it. And this quote from James Harlow at Twitter just nails the mindset. He says, a tester is concerned with making sure it never stops working. See the difference? A developer's job is to get it to work. A tester's job is to throw everything they can at it to make sure it keeps working, no matter what crazy thing a user does. It's a totally different worldview. So how do they do this? They use different kinds of test data. First, there's valid data. That's the normal stuff, right? Inputs that should work. Then, there's invalid data. You're trying to trip it up.
putting text where numbers should go, or leaving a required field blank. The system should reject it. And then my favorite, extreme data. This is where you push the boundaries. What happens if you enter the longest possible name, or just the number 0? You're testing the absolute limits.
And here's what a simple test plan looks like in action. Just look at that top row. The feature is addition. The test case? Super simple. Add 4 plus 4. The expected result is obviously 8. But look at the actual result. It's 44. Whoops. This is such a classic bug. The program is concatenating the numbers, treating them like text, and just smooshing them together, instead of doing math. This is exactly the kind of thing testing is designed to find. And you know, testing isn't just about finding logic bugs like that. Performance is a huge one. Listen to this from app developer Ivo Jansch. He said his team got slammed with criticism that their app was slow. Why? Because on their brand new top-of-the-line devices, it was super fast. But on older phones, it was a crawl. And that's a lesson right there. You absolutely have to test for the real world your users live in, not just on your fancy developer machine. So, what happens when this whole process breaks down? When testing is skipped or requirements are missed? Well, the consequences can go from merely frustrating all the way to catastrophic. The stakes can be unbelievably high. I mean, look at this. This is one of the most famous and painful examples ever. NASA's Mars Climate Orbiter. $100+ million spacecraft just lost in space. And why? Because one piece of the software was calculating in metric units and another piece was using imperial. That's it. A simple conversion error that should have been caught in testing led to a complete and total failure. And it's not just spaceships. These failures hit way closer to home. In 2022, a huge outage at Rogers in Canada took down pretty much everything. Internet, phones, payment systems. But the most terrifying part, people couldn't call 911. Access to emergency services was just gone. It's a stark reminder that software failures can have massive, real-world consequences for public safety and the entire economy. Okay, so we've looked at the map, we've explored the different routes, and we've seen the warning signs for the dangers ahead. Now, let's bring this all back home, back to you, and how you can use this blueprint to build your own career path. So, why should you care about all this? Here's the bottom line. When you go to apply for that tech program or that co-op job or your first internship, they're not just looking for someone who can write code. Anyone can learn to code. They are looking for someone who thinks like a professional, someone who can talk about the SDLC, explain why they chose a certain development model, and show a thought-out plan for testing their work. That's what gets you hired. So, I've got a little challenge for you. Let's put this into practice right now. Take that simple homework planner app idea. First, write down a single sentence for its main requirement. What does it do? Then, pick a development model and write down one sentence justifying your choice. And finally, draft 5 quick test cases, 2 valid, 2 invalid, and 1 extreme one. Seriously, this little exercise, this is the kind of thinking that will make you stand out in an interview. And that brings us to a final question to leave you with. Think about how you work right now. Are you naturally more of a waterfall person who likes to have a solid plan from start to finish? Or are you more of an agile person, adapting as you go? And then think bigger. Which model will stretch you? Which one will help you grow into the kind of professional you want to be? Because at the end of the day, understanding this blueprint isn't just about building better software. It's about building your future.